When we speak of the history of mushrooms, we must imagine not a simple culinary ingredient or a curious organism growing from a fallen log, but rather an ancient companion that has witnessed the rise and fall of continents, the drift of oceans, and the slow choreography of evolution long before the first human foot touched soil. If we could silence the world for a moment and lean close to the forest floor, tracing the mycelial threads woven beneath the leaf litter, we would be listening to a story older than mammals, older than trees, even older than complex life's earliest confident steps. Mushrooms belong to a kingdom that emerged in the Precambrian hush, when the earth itself still struggled to decide what life should become. The first fungal entities stretched across the barren ground of a world where plants had not yet mastered height, and where the winds carried the scent of raw minerals rather than blooming petals. In those remote epochs, fungi played the patient architect, digesting rock, releasing nutrients, preparing the planet for the flora that would one day rise in towering forests. And when, hundreds of millions of years later, the first trees finally reached skyward, fungi were already waiting for them, ready to form alliances so profound that forests themselves would depend upon their invisible networks to breathe, feed, and endure. From these early ages, where fossilized fungal structures such as prototeixites, a towering organism once thought to be a tree, rose several meters high, human history had not yet begun. But when human beings eventually stood upright and wandered through grasslands and woodlands, mushrooms became woven into the fabric of belief, medicine, mythology, and survival. Picture ancient gatherers emerging at dawn, scanning the mist-draped ground for the subtle bulge of a cap pushing through soil, knowing that some would nourish, some would heal, and some would send the unwary into the last sleep. In Neolithic settlements, clay fragments carry traces of spores, suggesting our ancestors stored, transported, and perhaps ritualized mushrooms in ways we are only beginning to decode. On the walls of prehistoric rock shelters in the Sahara and the mountains of Spain, anthropomorphic figures appear with mushroom-like appendages, as though early cultures understood these organisms as gateways to altered realms or symbols of transformation. Whether these depictions reflect sustenance, ceremony, or mystery is a question lost to time. But their presence underscores a truth. Fungi have always occupied a liminal space in the human mind, balanced between fear and fascination. Far to the west, on the sun-baked Mediterranean shores, where Greek thinkers shaped the foundations of Western philosophy, mushrooms found their way onto the plates of citizens and into the vocabulary of physicians. Hippocrates, the father of medicine, observed the antibacterial properties of certain bracket fungi, even if he lacked the words microbiologists would one day use. Aristotle commented on their enigmatic nature, noting that mushrooms seem to appear without seeds, a sentiment widely shared in an era predating microscopy. The Romans, for their part, developed a complex relationship with mushrooms, elevating delicacies like the Caesar's mushroom to high cuisine, while simultaneously fearing the toxic species that could slip into a feast unnoticed. Roman emperors had reason to be wary. The Emperor Claudius's death was long rumored to have been hastened by a poisoned mushroom dish, cementing the organism's reputation as both royal delicacy and political weapon. Beyond Europe's terraced farms and imperial courts, mushrooms shaped the mythic imagination of peoples across the globe. In the highlands of Mesoamerica, long before European contact, the Maya and the Aztec civilizations incorporated psilocybin-containing mushrooms into sacred ceremonies, calling them teonanacat, the flesh of the gods. Stone effigies carved with caps and stems, stylized into expressive faces, stood as silent witnesses to rites where participants sought communion with divine forces or glimpses into the cyclical nature of existence. These ceremonies were conducted with great reverence, under strict guidelines, and often accompanied by chanting, incense, and elaborate symbolic frameworks that tied the mushroom to cosmic origins and ancestral memory. As trade routes expanded and empires intertwined, mushrooms traveled as well, carried along in the memories, stories, and medicinal traditions of the people who used them. Medieval Europe saw a shift in the perception of fungi as the Church sought to categorize the natural world through theological lenses. Some mushrooms were condemned as unclean or associated with witchcraft, especially those that induced visions or grew in rings, patterns that folklore quickly transformed into the fairy circles where supernatural beings were said to dance through the night. Yet despite these superstitions, knowledge persisted among herbalists, midwives, and healers who recognized the practical benefits of certain species. Birch polypore, for instance, was used to sharpen blades and as a styptic to slow bleeding, properties so valuable that the famous prehistoric mummy Utsi carried pieces of it on a leather thong as he traversed the icy Alps more than 5,000 years ago. His possession of two different fungi, one medicinal and one useful for fire starting, provides a snapshot of how intimately ancient peoples understood the utility of these organisms. When the Renaissance unfurled its banner of curiosity and scientific revival, European scholars began to examine mushrooms with renewed skepticism and fresh techniques. Artists like Leonardo da Vinci studied their structures in sketches, intrigued by how they emerged suddenly after rain. Early botanists, lacking the category fungi, struggled to classify mushrooms within frameworks meant for plants. The invention of the microscope in the 17th century transformed this struggle into revelation as pioneers like Robert Hooke and later Antony van Leeuwenhoek peered into the hidden world of spores and hyphae. The discovery that fungi reproduced not through seeds, but through microscopic dispersal systems, challenged long-held beliefs and opened a new frontier of study. Meanwhile, cooks in Italy and France refined fungal gastronomy, integrating truffles and their intoxicating aroma into dishes fit for the courts of dukes and kings. The truffle trade became so coveted that entire forests were managed to encourage their growth, and dogs or pigs trained to locate them became valuable assets in the economies of rural villages. The Enlightenment brought still more rigorous inquiry. Naturalists such as Carl Linnaeus and later Christian Hendrik Persson wrestled with the taxonomy of fungi, attempting to impose order upon the dizzying diversity of shapes, colors, and ecological roles. Their classifications established the foundation upon which modern mycology would be built, even as new species were discovered across the colonies and territories explored by expanding European powers. Indigenous knowledge from Africa, the Americas, and Oceania enriched European understanding, revealing edible species unknown in Europe and toxic ones that required careful avoidance. In many cultures, mushrooms served as seasonal markers, appearing predictably at particular times of year and signaling moments for festivals, migrations, or agricultural cycles. By the 19th century, industrialization reshaped humanity's relationship with nature, carving railways through forests and funneling rural populations into cities. Yet mushrooms continued their quiet, parallel existence. Mycologists such as Elias Magnus Fries meticulously documented thousands of species, establishing naming conventions still used today. Meanwhile, the emerging field of microbiology began to uncover the deeper biochemical potentials of fungi. Yeasts, long used in brewing and bread making, were recognized as fungal organisms, performing fermentation through metabolic processes that could be manipulated, optimized, and eventually industrialized. The discovery of fungal pathogens that infected crops, such as the potato blight fungus Phytophthora infestans, which contributed disastrously to the Irish famine, forced governments and scientists to pay closer attention to fungi, not only as curiosities, but as forces capable of shaping geopolitical events. As the 20th century dawned, mushrooms leapt from folklore and the margins of botany into the heart of medicine. Alexander Fleming's discovery of penicillin, derived from the penicillium fungus, transformed healthcare and ushered in the antibiotic age. The realization that fungi could produce compounds capable of halting bacterial infections revolutionized pharmacology, saving millions of lives and prompting research into thousands of fungal species in search of new drugs. At the same time, psilocybin-containing mushrooms were rediscovered by Western ethnographers exploring Mesoamerican rituals, sparking a wave of interest in their psychological effects. This interest eventually clashed with political anxieties in the 1960s, leading to legal restrictions. But modern research has once again turned toward these ancient species for potential therapeutic use in treating depression, PTSD, and addiction. While science advanced, mushrooms retained their deep cultural resonance. In Japanese forests, the matsutake mushroom became associated with purity and the changing seasons, its aroma signaling autumn's arrival and carrying profound aesthetic significance in poetry and cuisine. On the Eurasian steppes, mushroom foraging remained a cherished tradition, passed down through generations with careful instruction on distinguishing safe species from deadly lookalikes, such as the death cap or destroying angel. Mushrooms whose elegant forms conceal some of the most lethal toxins known in nature. These traditions demonstrated a level of ecological literacy cultivated over centuries, where families taught children not only how to identify mushrooms, but how to read the forest itself, to understand the relationships between trees, soil, rainfall, and the fungal rhythms that tied them together. In the early decades of the 20th century, as nations industrialized at unprecedented speed, the quiet persistence of fungi contrasted sharply with the rhythms of factories and mechanized agriculture. Yet even amid coal smoke and the clatter of assembly lines, mushrooms continued shaping human destinies in ways subtle and profound. Scientists realized that fungi were not merely organisms to classify or ingredients to cook, but biochemical powerhouses capable of producing enzymes, pigments, antibiotics, and metabolic pathways entirely unlike those of plants or animals. Laboratories across Europe and North America began cultivating molds in controlled environments, initially for food research, but soon for a far broader array of purposes. When penicillin entered large-scale production during World War II, fungal fermentation shifted from academic curiosity to life-saving industrial process, its vats and cultures guarded as closely as military secrets. Meanwhile, agricultural researchers confronted fungal pathogens that threatened global food supplies, such as wheat rust and banana blight, forcing governments to invest in mycological expertise to protect harvests from diseases capable of crippling national economies.
Yet outside laboratories and academic halls, the relationship between people and mushrooms remained deeply rooted in tradition, memory, and seasonal ritual. In Eastern Europe, foraging seasons were social events where families ventured into birch forests at dawn, baskets lined with moss, each member entrusted with knowledge gleaned from ancestors who read the forest like a familiar manuscript. In the snowbound north, Sami and Chukchi herders continued ancient practices involving the Amanita muscaria, long entwined with spiritual roles and cosmologies that explained the movement of reindeer herds and the cycles of winter. In the Andean highlands, fungi growing from decaying wood were used as tinder, helping shepherds kindle fires in thin mountain air. These practices survived the encroachment of modernity because they were more than mere customs. They were expressions of cultural identity, woven into landscapes where mushrooms emerged as faithfully as stars punctuated the night sky. By mid-century, Western science pushed deeper into the mysteries of fungal biology, uncovering connections that rewrote our understanding of life itself. Researchers exploring forest ecosystems discovered that mycorrhizal fungi, long observed but poorly understood, were not simply nutrient couriers for trees. They formed vast interconnected networks that linked multiple species across entire woodlands. These subterranean webs allowed trees to exchange carbon, nitrogen, warning signals, and even chemical cues that increased resistance to pests. Some saplings, shaded beneath dense canopies, were found to receive sustenance from older trees through these fungal conduits, ensuring the survival of future generations. This revelation transformed forests from collections of individual organisms into living tapestries of cooperation, communication, and interdependence, with fungi acting as the silent intermediaries orchestrating the exchange. During this same era, explorers and naturalists ventured into rainforests, savannas, and high-altitude cloud forests, documenting mushrooms whose shapes and colors defied expectation. Delicate coral fungi that branched like underwater organisms, glow-in-the-dark species whose bioluminescent caps pulsed faintly in the humid air, massive bracket fungi that grew like wooden shells along fallen trunks, and parasitic species such as cordyceps, which burst from insects with eerie precision, their spores dictating the movements of ants or caterpillars in ways that blurred the boundary between life and death. These discoveries not only expanded biological knowledge, but also ignited the imagination of artists, writers, and filmmakers who found in fungi a source of visual wonder and narrative intrigue. Yet the indigenous peoples living in these regions had known these species for generations, integrating them into medicinal practices, diets, and mythologies that often contained insights science would take decades to confirm. As the century progressed, the interplay between mushrooms and economic systems became increasingly pronounced. The global demand for edible fungi surged, turning species like the button mushroom, shiitake, and oyster mushroom into billion-dollar industries. The cultivation of shiitake, once restricted to traditional Japanese log inoculation methods, became standardized and adapted for commercial farms worldwide, while truffle cultivation transformed from an unpredictable woodland pursuit into a methodical agricultural science. Regions in France, Italy, Australia, and later China experimented with inoculating oak and hazelnut groves with truffle spores, attempting to coax the elusive delicacy from soil carefully managed for temperature, pH, and moisture. Meanwhile, in the forests of Yunnan and Sichuan, diverse wild mushrooms, dozens of species gathered each season, became essential income sources for rural families, fueling bustling markets where traders inspected caps and stems with practiced eyes, judging freshness and species with expertise honed through years of foraging. Fungi also began entering the environmental spotlight as scientists realized
their unparalleled ability to decompose materials that resisted breakdown by other organisms. White rot fungi, for example, could dismantle lignin, one of the toughest organic polymers in nature, enabling the recycling of wood in forest ecosystems. Researchers soon discovered that some fungal species could degrade petroleum products, pesticides, and even certain plastics, opening new avenues for bioremediation in polluted soils and industrial sites. Experiments demonstrated that oyster mushrooms could reduce toxic residues in contaminated environments, offering a glimpse into a future where fungi might help restore landscapes damaged by human industry. These capabilities underscored a truth that ancient ecologies had long displayed. Fungi serve as nature's recyclers, transforming death and decay into fertile ground for renewal. In parallel with ecological research, advances in molecular biology revealed the staggering genetic diversity of the fungal kingdom. DNA sequencing uncovered relationships that defied earlier taxonomies, reshuffling entire branches of the fungal family tree and identifying cryptic species that had remained invisible to morphological classification. Some mushrooms thought to be widespread single species turned out to be dozens of genetically distinct organisms, each with unique ecological roles. These discoveries proved essential for conservation efforts, as habitat loss threatened fungi as surely as it threatened animals and plants. The decline of truffle-producing forests in Europe, the reduction of old-growth woodlands in North America, and the loss of tropical habitats worldwide put pressure on fungal populations that had evolved over millions of years. Conservationists, once focused primarily on charismatic megafauna, began to advocate for fungi as a crucial but overlooked component of biodiversity. Through all this, mushrooms maintained their enigmatic presence in art, literature, and philosophy. Surrealist painters depicted mushrooms as symbols of transformation, growth, and the uncanny. Poets used them as metaphors for sudden insight, hidden truths, or the fragile border between reality and imagination. Children's books portrayed forests dotted with red-capped toadstools as gateways to fantastical adventures, while modern science fiction reimagined fungal networks as sentient intelligences or alien ecosystems. These creative interpretations echoed the ancient sense that mushrooms existed on the edge of comprehension, appearing suddenly, thriving in darkness, and embodying a logic distinct from the orderly progression of seed to sprout to tree. As the 21st century approached, new questions emerged at the intersection of fungi and technology. Could mycelium, grown into dense mats, replace petroleum-based plastics? Could architectural forms be grown rather than built, using fungal composites that were fire-resistant, biodegradable, and lightweight? Early experiments proved promising, leading designers and engineers to explore materials created not through extraction, but through cultivation. Blocks of mycelium-based composites were tested for insulation, packaging, and even furniture, demonstrating strength and versatility that surprised manufacturers accustomed to synthetic polymers. In parallel, researchers investigated fungal pigments as sustainable alternatives to synthetic dyes, aiming to reduce the environmental footprint of the textile industry. The more scientists examined fungi, the clearer it became that their potential applications extended far beyond the boundaries of food, medicine, or ecology. Yet perhaps the most transformative revelations came from the continued exploration of fungal cognition, or what some cautiously referred to as the behavior of mycelial networks. Although fungi lack brains or nervous systems, experiments showed that mycelium could solve mazes, optimize nutrient paths, and respond to environmental changes with a form of distributed intelligence. Researchers placed networks of slime molds, distant fungal relatives, into complex arrangements mimicking transportation grids, discovering that they mapped efficient routes with remarkable precision. These findings sparked debates about whether intelligence must be centralized to exist, or whether life had evolved multiple strategies for processing information across different branches of the evolutionary tree. In forests, mycorrhizal networks continued to astound researchers with their complexity. Sensors placed in soil revealed that fungi moderated water flow, buffered trees against drought, and adjusted chemical exchanges during times of stress. When pests attacked one tree, fungal conduits carried biochemical warnings to neighboring trees, prompting them to increase defensive compounds even before the threat arrived. These interactions suggested that forests behaved not as isolated organisms, but as collective communities shaped by fungal mediation. Such discoveries challenged traditional ecological models and invited a more holistic understanding of ecosystems as collective entities rather than assemblages of competing individuals. Meanwhile, archaeological studies unearthed new evidence of mushrooms in ancient societies, from residues on pottery in prehistoric India to ceremonial artifacts in Bronze Age Europe that hinted at ritual usage lost to written memory. Linguists traced the etymology of mushroom-related words in dozens of languages, uncovering how cultural perceptions shaped vocabulary. Some emphasized shape, others habitat, others taste or danger. These linguistic threads illustrated how fungi had quietly permeated human consciousness, influencing metaphors, proverbs, and even religious symbolism. In some cultures, mushrooms represented sudden fortune. In others, they symbolized impermanence, given their ephemeral emergence after rain. As global travel expanded, mushroom species traveled with it, intentionally or accidentally. Spore-laden soil in horticultural shipments introduced foreign fungi to new continents, sometimes with dramatic ecological consequences. Invasive fungal pathogens devastated amphibian populations, threatened iconic tree species like American chestnuts and European elms, and altered entire ecosystems where native species had no defenses. These biological invasions underscored the complicated relationship between mushrooms and human activity. Fungi could heal or harm, nourish or devastate, depending on the context in which they spread. The rise of amateur mycology communities in the digital age further transformed humanity's engagement with mushrooms. Online forums, identification apps, and citizen science projects enabled enthusiasts to document species, map distributions, and share knowledge worldwide. High-resolution photography captured the delicate gills of minute forest mushrooms, the fractal folds of chanterelles, and the intricate labyrinths of boletes, revealing details once accessible only to specialists. This surge of public interest revived traditional foraging in many regions, brought new attention to fungal conservation, and encouraged interdisciplinary collaboration between scientists, artists, chefs, and environmentalists. By the dawn of the 21st century, the cumulative weight of centuries of observation, ritual, science, and folklore converged into a new era of fascination with fungi, as though humanity, having circled the natural world many times, had finally returned to a companion quietly waiting beneath its feet. Mycologists, environmental scientists, architects, pharmacologists, and even computer scientists began to recognize fungi not as peripheral curiosities, but as fundamental actors capable of reshaping how societies understood resilience, adaptation, and interconnectedness. In university greenhouses and forest research stations, teams cultivated rare mushroom species once thought impossible to grow outside their native habitats, each success revealing hidden biological strategies honed through millions of years of survival in environments ranging from Arctic tundra to equatorial jungles. These breakthroughs offered glimpses into evolutionary puzzles, how mushrooms coordinated the timing of their fruiting bodies with rainfall cycles, how spores dispersed across vast distances without wings or locomotion, and how certain species resurrected themselves from desiccated states after lying dormant for months or years. As field researchers trekked through remote landscapes, they documented fungal species with properties that bordered on the surreal. Deep in the limestone caves of Southeast Asia, delicate mushrooms emitted a soft blue-green luminescence, their glow illuminating cavern walls with a rhythm reminiscent of breathing. In volcanic regions of Iceland and Kamchatka, heat-tolerant fungi clung to the edges of geothermal vents, thriving in temperatures that would kill most plants within seconds. In the dense canopies of Borneo, epiphytic fungi sprouted from decaying leaves suspended high above the forest floor, their spores drifting down like microscopic snow. These discoveries challenged assumptions about where life could flourish and prompted new lines of inquiry into the adaptability of fungal enzymes which continued functioning under extreme heat, acidity, or dryness, traits that would later inspire innovations in biotechnology and industrial chemistry. Within urban environments, mushrooms emerged as surprising participants in ecological restoration efforts. Vacant lots, abandoned industrial sites, and polluted riverbanks became testing grounds where environmentalists deployed fungal species capable of breaking down petroleum residues, heavy metals, and chemical pollutants. These experiments demonstrated that mycoremediation, once a fringe idea, held genuine potential to transform contaminated landscapes without resorting to excavation or chemical treatments that strained municipal budgets. In some pilot projects, mycelium was paired with plants in synergistic systems that restored soil fertility, attracted insects, and fostered conditions for native vegetation to reclaim areas long considered ecological dead zones. Observers noted not only the scientific efficacy of such efforts, but also the symbolic resonance. Mushrooms, long associated with decay, became instruments of renewal. Simultaneously, the culinary world was undergoing its own transformation as chefs developed an unprecedented appreciation for the sensory complexity of fungi. High-end restaurants sourced rare species such as the crisp-skinned matsutake, the aromatic black trumpet, and the intensely savory morel, treating them not as garnishes, but as stars of intricate dishes. Molecular gastronomists experimented with fungal broths, extracts, and fermentations, discovering layers of umami that surpassed even fish sauce or aged cheese. Meanwhile, home cooks rediscovered traditional practices such as drying porcini in mountain air or marinating forest mushrooms in vinegar and herbs, reviving culinary methods nearly lost during the industrial food era. Markets in Eastern Europe, East Asia, and the American Pacific Northwest bustled with seasonal trade, baskets overflowing with golden chanterelles, indigo milkcaps, peppery russulas, and massive king bullets that commanded prices rivaling fine cuts of meat.
In laboratories dedicated to pharmacology, fungal compounds revealed therapeutic potential beyond what previous generations had imagined. Researchers analyzed immunomodulating polysaccharides in reishi and turkey tail mushrooms, investigating their roles in supporting immune function and complementing cancer treatments. Cordycepin, derived from species of cordyceps, demonstrated antiviral and anti-inflammatory properties that placed it at the forefront of drug development programs. Meanwhile, psychoactive mushrooms, once studied in tightly restricted environments, entered a new phase of clinical trials, exploring their ability to alleviate depression, anxiety, and trauma. These trials, grounded in rigorous methodology and careful regulation, revisited knowledge that indigenous cultures had safeguarded for centuries, translating ancient ceremonial wisdom into frameworks compatible with modern medical ethics. Even as scientific exploration advanced, the cultural identity of mushrooms continued evolving in unexpected ways. Fungal aesthetics seeped into fashion, architecture, and digital art, where designers drew inspiration from the fractal geometry of gills, the iridescence of certain spores, and the sweeping curves of mushroom caps.
Concept artists envisioned biomorphic cities grown from mycelium-based materials, while fashion houses experimented with fabrics dyed using fungal pigments or treated with mycelium-derived finishes. Mycelium leather, durable, soft, and grown in days rather than harvested from livestock, entered showrooms, offering consumers an environmentally conscious alternative to traditional hides. Furniture companies introduced lampshades, stools, and wall panels grown from cultivated fungal composites, each piece uniquely textured by the organic growth patterns that replaced industrial molds. Meanwhile, mycologists continued to expand humanity's understanding of the ecological roles played by fungi in natural environments. In tundra ecosystems, fungi formed survival partnerships with mosses and lichens, enabling life to persist in climates where nutrients were scarce and temperatures severe. In grasslands, endophytic fungi living inside plant tissues conferred drought resistance and protection against herbivores, influencing the distribution of plant species over thousands of square kilometers. In tropical rainforests, fungi participated in intricate symbiotic webs involving insects, plants, and microorganisms. Webs so complex that even small disruptions could ripple outward, altering the balance of entire ecosystems. These findings illuminated the fragility of environments once assumed to be self-sustaining, revealing the extent to which global ecological stability depended upon fungal diversity that most people never saw. As environmental crises intensified, climate change, deforestation, biodiversity loss, conservationists and policymakers began to recognize fungi as indispensable allies in preservation efforts. Proposals emerged advocating for fungal inclusion in international conservation frameworks, urging governments to protect not only forests and wetlands, but the fungal species that maintain their ecological functions. Citizen science played a pivotal role in these efforts, as thousands of enthusiasts cataloged sightings, uploaded photos, and helped researchers map fungal occurrences across continents. This collaboration between experts and amateurs enriched databases that informed land management decisions, climate models, and biodiversity assessments, turning fungi into one of the best documented yet still least understood kingdoms of life. Across universities, interdisciplinary teams examined the philosophical implications of fungal networks, drawing parallels between their decentralized communication and human systems such as the internet, city planning, and collaborative governance. The idea that intelligence could arise from distributed, non-hierarchical structures, so different from the nervous systems of animals, challenged long-held assumptions about cognition, perception, and agency. Some theorists speculated that fungal networks represented an ancient evolutionary pathway toward problem-solving, one that predated brains and could illuminate principles applicable to advanced computing or artificial intelligence. Whether or not such parallels held, they demonstrated how mushrooms continued to inspire inquiry far beyond biology. Archaeologists, too, uncovered deeper connections between fungi and early technological innovation. Studies of prehistoric hearths revealed fungal remnants used as tinder, enabling early humans to transport fire across landscapes. Analyses of ancient dyes found that certain pigments originated from fungal sources, indicating that artisans had once harnessed fungal chemistry for painting textiles and ceremonial objects. In some regions, the earliest forms of fermented foods and beverages showed traces of molds that played critical roles in preserving grains, fruits, or dairy, underscoring how fungi had contributed to the foundation of human civilization as surely as metallurgy or agriculture. As all these threads converged, the modern world found itself standing at an unexpected threshold. Mushrooms, long relegated to the background of natural history, emerged as guides towards sustainable technologies, ecological restoration, and new philosophical paradigms. Their ancient lineage, stretching back to eras when continents were unrecognizable, provided a humbling reminder that humanity's tenure on Earth was brief compared to the evolutionary saga of fungi. And yet, in that brevity, humanity had begun to rediscover a truth that traditional cultures had preserved, that the world beneath our feet is alive with networks older and wiser than the societies built above them. Networks capable of supporting life, healing landscapes, and inspiring new visions of how civilization might coexist with the natural world. In the early decades of the new millennium, as climate models grew more dire and resource scarcity loomed over international policy discussions, fungi re-entered the global conversation not as background organisms, but as catalysts for new strategies of survival. In think tanks from Berlin to Seoul, researchers examined how fungal resilience might inspire new infrastructure designed to withstand rising temperatures and shifting weather patterns. Mycologists presented data demonstrating how certain mycelial networks survived drought by redirecting internal moisture, or shielded themselves from heat by forming dense protective layers woven from microscopic filaments. Engineers who studied these natural responses soon proposed analogous systems for buildings that could self-insulate, heal microfractures, or adaptively redistribute structural stress, all modeled on the architecture of fungal tissues that had endured millions of years of environmental upheaval.
Meanwhile, in the world's forests, some shrinking, others recovering, scientists monitored how mushrooms responded to changing climates. In northern boreal regions, warming temperatures allowed species once limited to temperate zones to expand their range, altering soil composition, nutrient cycles, and the growth patterns of trees that had evolved with different fungal partners. In the Amazon basin, intensified droughts shifted the timing of fungal fruiting seasons, prompting indigenous communities to adjust traditional gathering practices that had remained unchanged for generations. These shifts were small on the scale of human lifetimes, but profound in ecological terms, signaling that fungi,
though adaptable, were not invincible. Conservationists realized that safeguarding fungal diversity required protecting not only individual species, but the intricate relationships between fungi, plants, animals, and climate. Relationships formed through interactions so subtle they often escaped human notice until disrupted. Yet these challenges did not diminish the creative possibilities fungi offered. In research labs devoted to sustainable materials, scientists refined techniques for cultivating mycelium into dense, moldable forms that could replace synthetic foams, plastics, and even structural components. Mycelium-based insulation began appearing in eco-friendly homes, praised for its fire resistance and biodegradability. Experimental bridges made from mycelial composites were tested in controlled environments, their unexpected strength impressing civil engineers. Startups across Europe and North America grew packaging materials from fungal fibers that decomposed in weeks rather than centuries, offering major corporations a way to reduce environmental impact without sacrificing durability. For the first time in industrial history, a material that grew quietly in darkness could compete with products derived from petroleum. Parallel to these technological developments, communities around the world revived cultural traditions that had once centered on fungi but had faded under urbanization. In the Carpathian Mountains, festivals dedicated to mushroom foraging returned, drawing participants from distant cities eager to reconnect with ancestral knowledge. Elders guided newcomers through forests, teaching them how to read subtle clues: soil moisture, the presence of certain trees, the curled edge of a leaf, to determine where prized species might emerge. In Russia, old recipes for preserving mushrooms through salting, fermenting, and smoking experienced a renaissance, celebrated not as nostalgic curiosities, but as demonstrations of regional identity. In Oaxaca, families passed down ceremonial uses of psilocybin mushrooms with renewed emphasis on tradition, resisting commercialization while honoring rituals grounded in centuries of reverence. Even as cultural practices endured, scientists delved deeper into the genomic complexity of fungi, sequencing entire fungal ecosystems to understand how species interacted within the same patch of soil. These metagenomic studies revealed unexpected alliances between fungi and bacteria, partnerships that influenced nitrogen fixation, carbon storage, and the decomposition of organic matter. They showed that fungal communities responded to disturbances, fires, floods, logging, not randomly, but with strategies optimized for ecosystem recovery. Some species colonized burned landscapes within days, stabilizing soil and preventing erosion, while others decomposed charred wood, returning nutrients to the recovering forest. In floodplains, water-tolerant fungi broke down leaf litter that would otherwise choke waterways, playing an unsung yet indispensable role in river health.
These discoveries reshaped global understanding of carbon storage, a key factor in climate policy. Mycologists demonstrated that mycorrhizal fungi significantly influenced the carbon balance of forests, often determining whether ecosystems functioned as carbon sinks or sources. When fungal networks supported deep root systems, carbon from photosynthesis flowed into the soil, where it remains stored for decades or centuries. But when fungal networks were disrupted by logging, pollution, or climate stress, this balance unraveled, releasing carbon into the atmosphere and exacerbating global warming. These findings placed fungi at the center of international discussions on reforestation and land stewardship, elevating them from ecological footnotes to essential participants in climate mitigation strategies. At the same time, the study of fungal communication continued to captivate researchers across disciplines. Experiments showed that electrical impulses traveled through mycelial networks with patterns reminiscent of neuronal firing, although vastly slower. When one part of a fungal network encountered nutrients or toxins, nearby segments adjusted their behavior accordingly. These electrical signals varied between species, suggesting forms of communication unique to each type of network. Some scientists speculated that these patterns represented a kind of proto-language, an ancient system of information exchange that predated the evolution of nervous systems. Whether or not such comparisons held literal truth, they emphasized how fungi processed environmental information with a sophistication that defied earlier perceptions of fungi as passive organisms. Meanwhile, the economic importance of mushrooms reached new heights. Global demand for gourmet varieties surged, driven by rising interest in plant-based diets and flavors that offered alternatives to meat. Shiitake farms expanded across Europe, North America, and Africa, where controlled environment agriculture made large-scale cultivation feasible even in regions without traditional mushroom-growing cultures. Lion's mane, once a rare specialty, became widely cultivated for both culinary and medicinal markets, its delicate strands resembling the tentacles of an otherworldly organism, and its compounds attracting attention for potential neuroprotective effects. Truffle cultivation, once an unpredictable endeavor, became increasingly refined through advances in soil science and microbiology, turning orchard-style truffle farms into long-term investments for entrepreneurs seeking high-value agricultural ventures. Beyond commerce, a new generation of artists and storytellers wove mushrooms into creative works that captured public imagination. Novels explored worlds shaped by fungal intelligence, while artists sculpted installations from mycelium, allowing their pieces to grow, shift, and decay as part of the artwork. Musicians incorporated field recordings of spore release and fungal growth, sounds too quiet for human ears until amplified, into experimental compositions. Video game designers imagined societies where fungal networks served as communication grids or organic architecture. These artistic explorations highlighted the symbolic versatility of fungi. They could represent decay, renewal, transformation, interconnectedness, or the uncanny intrusion of nature into human-made spaces. Even in medicine, fungi continued to produce revelations. Clinical trials investigating psilocybin-assisted therapy demonstrated remarkable outcomes for individuals with treatment-resistant depression, prompting renewed debate about the relationship between consciousness, neurochemistry, and ancient botanical rituals. In parallel, researchers discovered new fungal metabolites with potential applications in treating inflammation, metabolic disorders, and antibiotic-resistant infections. Mycologists found species with antiviral properties in remote regions, prompting expeditions to document fungi in biodiversity hotspots before habitat loss rendered such discoveries impossible. Each new compound underscored the vast pharmaceutical potential hidden within fungal diversity, a potential that would remain largely untapped unless protective measures ensured the survival of ecosystems that nurtured these species. But perhaps the most profound shift occurred in how people conceived of themselves within the natural world. As public awareness of fungal networks grew, the metaphor of the wood wide web entered mainstream culture, reshaping how communities viewed forests, farmlands, and even urban parks. People began to imagine cities not as isolated human constructs, but as living systems intertwined with soil organisms, waterways, and root networks. Gardeners inoculated their soil with mycorrhizal spores, recognizing that plants connected to fungal networks grew taller, fuller, and more resilient. This shift in perspective encouraged a broader ecological humility, inviting society to consider that thriving systems often depend on unseen relationships sustained by organisms that receive little public recognition. And beneath all this, beneath the innovations, the culinary renaissance, the renewed cultural traditions, and the scientific breakthroughs, the ancient presence of mushrooms continued much as it always had. While satellites circled the planet and servers processed trillions of digital exchanges, mycelial networks quietly expanded beneath forests, grasslands, and city parks, exploring new pockets of soil with patient tendrils. Fruiting bodies still emerged after rain in the same patterns that had appeared for millennia, their gills releasing spores into winds that carried them across continents. Fungi that had survived ice ages, volcanic eruptions, and mass extinctions persisted with understated confidence, their life cycles unfolding on timescales that dwarfed human history.